Okay, so this is a journey into music and sound with math engineering and MATLAB, and this is part 3 of our series. What I'd like to start off with first in this video is to start off with an overview of what we'll be talking about throughout the entire uh, video here. So first we're going to start off with a mini review of part 2. After we've done that, we're going to get into really what part 3 is about, and that's about part 3 is really about playing digital music in reverse and increasing the volume on that of that music. Okay, so let's start off with our mini review first. And remember, in part 2 we said that music can be stored as a set of discrete values, and these values may be stored in a fashion or in a structure that we may call a vector. Now you have two different types of vector. You have row vectors and you have column vectors. To say that we are storing something as a row vector, what it means is that we have this variable here which we call y, and we're storing these values in row fashion. Okay, and those values that we're storing, those discrete values, for example in this case is 1 2 3 4 5 so on and so forth, all the way till the very end of the vector. Now we can also store values in column vector form, and in column vector form this looks at this way: 1 2 3 4 5 so on and so forth. Now here's the thing about the vectors here. This is not how they're stored in memory, but what this is these two ways are two ways to help the human observer be able to envision how the vector of samples are being, uh, I guess you can say, being stored but not stored in memory, or being put together. Okay. All right. So now, given that that's the case, we finished the review. Let's look at how we actually take the music and reverse that music. So from part 2, we stored our information as a column vector. So again, that starts from 1 and it goes down all the way till the end of the song, which is in N. Okay. Now, if we want to reverse the music, what we need to do is we need to make the last value of the song the first value, and the first value of the song the last value, and change all others in between so that they match that pattern. And the way that we'll do that is we will use the flip UD, or flip upside down, function within MATLAB in order to do so. Okay, and then we'll put the vectors variable name within here. So if we want to flip upside down this vector, we would put y in here. So it'd be flip ud, open parentheses, y, close parentheses. Okay, and what that would end up doing is taking again the last value of the original vector y and putting it first, and the first value putting it last, and flipping all the others in between. Okay, in this fashion. And by doing this, we would end up being able to play our music in reverse. All right, so now that we've finished talking about that, what about increasing the sound level? Well, you may think that in order to increase the sound level, all we have to do is increase the amplitude of each of the samples that are stored by some given value larger than 1. So let's say, for example, the number 2 here. We can increase the vector 2 by multiplying the vector components here. So we multiply the vector by 2. So that means we go in and we multiply the first value by 2, second value by 2, third, so on and so forth. Okay. Um, However, by doing this, it does not mean that we increase the volume of the sound by 2, or the volume of the song by 2. Okay, or increased it 2 times as loud, or make it 2 times as loud. What we end up doing is the amplitude increased by 2, but the sound doesn't. And the reason that's so is because humans' perception of sound levels or changes in loudness does not model a linear model, as was shown on the previous page, but rather models a logarithmic scale, and that's a math function that we're talking about there. Okay, so for example, let's say if we wanted to hear something that, if something was to appear twice as loud to us, what happens is we actually need to multiply that by 10 in order for it to sound twice as loud to us. And this would mean that we get an increase of 10 decibels. Okay, you may have heard the term decibels before, and that's a term that you'd hear a lot of times in music, and we'll talk about that in a little bit. Okay, so given that that's the case, all right, in terms of loudness, what we're saying in terms of loudness is that if we were to take some reference song and we say, okay, it's X loud, and then form a ratio with, let's say we increased or decreased that loudness and formed a ratio between those two, that reference loudness and the second loudness that we have, okay, and then take log base 10 of that, multiply that by 33.22, we would get some value in decibels that represents the change in loudness in decibels. And if we were to take the intensity, so in other words, we look at one value within the vector as a reference and then compare it to another value, or that value then either increase or decrease by multiplying it by, let's say, a number 10 or 5 or whatever, okay, and forming a ratio with that, then taking log base 10 of that multiplied by that by 10, we'll end up getting another value in decibels. Now the thing is, if we take the two of these here together, we can actually put them, make them equal to 10 decibels, and we can make them equal to 10 decibels here by saying, okay, if we take some reference song that has a specific loudness, multiplied that reference level by 2, okay, and then take log base 10 of that, multiply that by 33.22, that will give us a change of 10 decibels. And so if we did the same thing though, but we're using intensity over here, multiply the intensity of some reference value found within the vector by 10, okay, and then take log base 10 of that, multiply that by 10, that would also give us 10 decibels. So in other words, then if we increase the intensity by 10, then it sounds like we've increased the loudness by 2. Okay, so you see that relationship. All right, now that we've done that, let's go ahead now and look at our Matlab program over here. And let's start from the top. Remember, we've created these values and variables and strings, okay. And then in this area of the file here, remember what we're doing is we're reading in the value. So we're using the wave read function in order to pull the values from the wave file into MATLAB. We're storing our values in the vector Y. We've found our sampling frequency and the number of bits. Okay, I'm going to skip over this part here. And remember then in this part here, what we did was we plotted some of the amplitude values. Okay, we plotted, as a matter of fact, the first 80, not the first 80, but 59, 5,922, 6,000. We've plotted those values in a figure here, figure 1. Okay. And so now what we're doing in this video is we're now going to flip those values that were stored in Y that we extracted from the music. Okay, we're going to flip those, and then we're going to end up playing the song backwards. So let's go ahead and do that. Okay, so we flip using that, and then we're going to make it play the sound backwards using this right here, line 38. All right, so here we go. Okay, so actually the music didn't start yet. We need to hit it one more time. This just shows up our information here. Let's go ahead and hit it one more time. Okay, so that was the song being played in reverse. And what you may have noticed is as the song was playing or beginning to play, these two screens popped up. So figure one was what the amplitude that we had from before, and figure two actually, what happened was we increased the amplitude by multiplying it by 10 here, 10 dot times y, actually multiplies all the values within by 10, and then we ended up plotting that information, so that part is already done. So the only thing that's left to do now is actually to play the song now at a louder amplitude, which is what I'm about to do, okay? And just real quick here, I'm going to pull these two back up. You'll notice that the amplitudes here have been multiplied by 10. Okay, let's go ahead and play the music louder. All right, so in this video, we explored reversing music and also increasing the loudness or volume of music. Again, this was a journey into music and sound with math, engineering, and Matlab. And this was part 3 of our series. Please do look for part 4 of the series on YouTube. And if you have any additional questions or you'd like to explore these topics just a little bit deeper, you can also check out my website. My website is at www.clydeletsom.com. Again, that's www.clydeletsom.com.